record the meeting. Yes. So the meeting is recorded here. I'll just give you again a brief overview of what that we are going to cover here in the module 4. Right? Like I said earlier, in the module 4 we are going to cover the Bayesian learning, introductory part of Bayesian learning, and what is Bayes theorem, which is again very important core concept of machine learning, and the concept learning here in Bayes theorem, the ML and LS error hypothesis. We are going to also study the ML for predicting probabilities, for which we require some basic concepts of basic understanding of probability as well, and the MDL principle, the naive Bayes classifier, which is also a part of your lab experiment, and the Bayesian belief network, and ultimately the EM algorithm, that is the expectation maximization algorithm. So this is a brief overview of the syllabus that we are going to cover here in the module 4, which is again a core aspect of machine learning when we talk about predicting different models. And also this is very important from the lab experiment point of view. So our machine learning lab, which will cover around 3 experiments from this particular model itself. So with this, let me ask you the question again. What is a network according to you? Muhammad Arif says two computers connected to each other in order to share data is called a network. Right, so that's a network. Talking about the computers, but can you relate to an example? Like we have already, like I mentioned earlier, we have already studied what is a network, what is a neural network, what is a multi-layered neural network in our previous module, module 3, right? So can you relate a network with respect to machine learning, right? How a network can be defined here in machine learning? Can you come up with a more suitable uh, definition for that? Yes, your definition is right. That two computers connected, two or more computers connected to each other in order to share data or share some information, right? Can be called as a network. But I want you to relate to the subject that we're studying right now, that is machine learning. So, how a network, what is a network? What are the different entities in a network? Right? Hope you can recall the diagram that we have seen in the module 3 for the multi-layered neural network. We have different layers there. We have different entities there. Something, can you recall those things and can you connect it to a network in a machine learning? Right? Anybody else with a more appropriate definition from network in machine learning? Yeah, you all have given the second eye. It was, I mean, the syllabus of the question for second eye was the artificial neural network. You have so many questions related to networks and you have successfully answered them. So I hope it shouldn't be a problem to at least define what is a network according to you. Right now. Okay, I think I have to pick. Yeah, Nikita. Nikita, if you can hear, can you answer? What is a network according to you? Any raw definition or your raw understanding of what is a network is accepted. Nikita, am I audible to you? besides mentally absent, I guess. Yeah, anybody else? So this gives me a fair idea that you guys, how attentive you guys are in the class, and how much you are concerned about answering the question that have been asked here in the class. Right? To be very frank, just if you are here for the attendance sake, it is better if you don't attend the classes just for attendance sake. Right? The main motive of being conducting this online classes is to uh, keep you in touch with the syllabus, the portion, the subject that we are learning here. Right? Attendance is not the factor. If you are spending time attending the classes here, make sure that it is worth while attending, and you give your 100% while attending the classes. There is no point in just clicking on the link which has been given to you and making sure that you've got the attendance for that class. That won't help you, right? Anyways, you are mature enough to understand these things, but coming back to the question, can anybody answer a simple question which even a second semester student can answer? What is a network? Or if your answer is right, very much right, but can you reframe your statement to uh, which can be relatable to this subject, that is machine learning? What is a network in machine learning?
Sir, so it is used to find the relationship between the input and the output values, or to find patterns in data. It's
Very
called
good.
network.
Yeah, very good example. Yeah, it can be to find the relationship between the values which has been supplied from the input to some intermediate nodes. To be very specific, nodes are the important terms here. A different node can be anything. It can be a computer itself, or it can be different model, or it can be subsystem inside a main system, right? So node can be anything. Like for example, in the multi-layered neural network, we saw a network which has nodes, but those nodes are nothing but the neurons, right? We saw perceptrons. So network in with respect to machine learning, or how it can be defined as in very raw terms, that anything like you mentioned, that to define a relationship between the two entities, right? It can be from input to intermediate node, or intermediate node to output, right? And then predict something or compute something out of it, calculate something to perform some analysis, right? So with this very basic understanding of what is a network, let us go ahead and understand what can be defined as a Bayesian network, right? What do we call a Bayesian network? So a Bayesian network, like other network, is also a graphical model, right? A network is nothing but it's a graphical model, right? So a Bayesian network is a graphical model for depicting probabilistic relationships, right? So as you mentioned, to find out a relationship between two entities, let us not restrict it to from input to output or input to any intermediate node. Let us generalize it more to understand from the relationship which can be from any node to any other specific node, right? It can be any, it can be both input node, or both can be intermediate node, or vice versa, or anything. So it's a combination, right? So a Bayesian network, like other network, is also a graphical model for depicting the probabilistic relationship. Now, this term is very important here. That is, we are not defining any, any random relationship there. We are defining the probabilistic relationship. So, whatever the computation that we'll be doing, we are going to be uh, computing those things with respect to the probabilistic concept, right? The data, whatever the data that we get, we are going to first compute the probability of that data, and then relationship between the probability that we have computed, and so on. Right. So, what probability? Probability of what? Depicting probabilistic relationship of what? So, this probabilistic relationship is amongst the a set of variables. Now, now, what are these variables? These variables can be different values, different nodes present inside the network. So this Bayesian network, they have different, little more different, more complicated concepts here, which will be further understanding more in depth as and when we proceed in the uh, module. But just to give you an overview, that the Bayesian network, it encodes the conditional independence relationship, right? What are these conditional independence relationship? We will take an appropriate example when we encounter this conditional independence relationship furthermore in the module, right? But this conditional independence, as the name suggests, conditional independence relationship, it is between the variables inside this graphical model, right? Or this graphical structure. So what it provides us a representation of the joint probability distribution over all these nodes or all these variables that we have, right? So let's say we have a problem domain modeled by some variables from x1 to xn, like we have been doing in the previous module, the multi-layered neural network or artificial neural network. We had different inputs right from x1, x2, and so on till xn, and then weights associated to those input values, right? But here, let's consider only the list of these variables that we have, and we are going to play with those values which are there as input, right? Now, this problem domain, the problem domain to model from a list of variables, the knowledge about this problem domain is represented by a joint probability of these list of variables, right? Because not one variable can define the overall probability of the network. Like since it is a network, one entity or one node cannot define the whole network, right? Of course, it is a part of the whole network, but we cannot compute the whole network, or we cannot judge a complete network only basis of one node. So we have to consider the joint probability of all the input variables or the list of variables that we have. So the probability of all the variables that is from x1 so on till xn will be considered. And after computing that probability, the knowledge that we get can be considered for the probabilistic relationship. So for this, we need to have directed links represent, right? Also called directed uh, cyclic graph. So we will see what are these directed or cyclic graph, directed cyclic graph, why we have directed or sometimes undirected, right? So, but in this case, we will have directed links represent casual direct inferences, right? Casual direct inferences, and each node in the network has a conditional probability table, right? What is this conditional probability table? We will shortly see. And this conditional probability table quantifying the effect from the previous node, which is also called as the parent node, right? And the one of the condition for this Bayesian network, which is that there is no directed cycles, right? I hope you by now you know what is a directed cycle and undirected cycle, or a directed acyclic graph, or directed undirected cyclic graph, right? I hope I think we have learned in the second model as well. Anyways, so this is the overview of what can be a Bayesian network. Uh, just the representation and the overall depiction that we are doing, that is the probabilistic relationship that we are doing. So that gives you a fair idea that, you know, in what all areas or which all problem domain can we apply this Bayesian network. Can anybody give me an example considering these factors, like depicting the probabilistic relationship, or predicting some probability and these things? Can anybody give me an example? Since you guys are working on the final year project, can you give me an example that which are the tentative, or potential, let's say, let's term it as potential problems wherein we can apply this Bayesian network? Anybody? See, we are talking about the probabilistic relationship, right? We are talking about the probability, that is the chances. of having something, right? So what I can think of that few problems which can be well suitable problem for the Bayesian network, wherein Bayesian network can be applied. That is where we see some chances of happening something, right? It can be chances of winning a game, that is nothing but prediction, right? A chances of having a kind of a disease, which is nothing but diagnosis of a particular disease, right? Cancer or anything. You guys are working on project which tells about whether a particular person has a particular kind of disease, yeah or no, right? So Bayesian network can be one such concept of machine learning, which where it can be applied on that particular model, right? So wherever when we talk about probability, it is all about chances, and when we talk about chances, predictions, then we can think about the problems like I said, winning, chances of winning a particular, uh, chances of player winning a particular game, then chances of a person having a particular disease, then you can say a chances of, uh, let's say, drawing a card out of a box. So everything which can be related to probability, right? Chances of having a heads or a tails after tossing a coin. So these are the predictions. Right. So let's say a very simple example. The first problem that comes when we talk about probability is tossing the coin, right? We have seen so many examples of probability of getting a head or a tail, combinations of these tossing coins and so on. So can we create a model? Can we create a system wherein, given the prior data of a particular coin, like a coin and the probability of having a head or tail, and some history of data, some prior data, a data set to a system, that these are the number of times this particular coin has given heads, and these are the number of times the particular coin has given tails. So making the system learn that what will be the next prediction is one such very simple example. Of course, it's not even, you know, um, this model cannot be applied anywhere, but just to give a illusion of how, where or places this particular algorithm can be applied, right? Or similarly, detecting a particular disease in a leaf, right? Whether a plant is suffering from a particular disease or not, right? So that is nothing but a probability, right? Given the soil condition, the type of the soil, the wind, the climate, right, and the health of the plant. So given these parameters, can we make a decision uh, considering the probability that whether this particular plant is infected or not infected? So this can be one more example of a problem domain wherein we can apply this Bayesian network. Right. Of course, there are a few more machine learning algorithms, or you can say machine learning concepts, which can uh, more accurately define these problems and give more better solution. But having said that, that doesn't mean that Bayesian network is not worthy enough. Right? Bayesian network also has its own advantages. So with this basic understanding, let us go and discuss what is directed acyclic graph, right, or also called as DAG. So, as the name suggests, it is a directed but acyclic graph. That means the nodes in the graph will be having a direction. Like one node will be pointing to another node, another node will be pointing to some more nodes, and so on. So, it is a directed, right? And when we have directed graph, that means we have some restrictions. We have been told to move from this node to that node only, right? There is a direction, predefined direction associated from one node to another. So we have a direction already set. But in undirected graph, you might not have any direction, so it can be both the ways. So that's not a concern here. In our Bayesian network, it is a directed per cyclic graph. So that means in the Bayesian network, all the nodes will have some direction pointing to some other nodes, right? Unless it is a leaf node. And a cyclic graph means, of course, there will be no node which can form a cycle, right? three nodes, node 1 pointing to node B, node 1 pointing to node 2 pointing to node 3. But node 3 cannot again point to node 1 because uh, that will not be a suitable network for the Bayesian theorem, right? So we need to have acyclic. Right? There shouldn't be any instance in the complete network which forms a cycle, right? So there should be no cycle in the complete graph. If we have these two conditions, that is, we have direction set and we don't have cycle inside the graph, then that is called as a directed acyclic graph, and that graph that model is what the Bayesian network makes use of. So let us go ahead and understand with an example here that, and as you can see, we have four nodes A, B, C, and D, right? And as you can see, there is already a predefined set direction, right? So point node A is pointing to node B is pointing to two more nodes, that is C and D, which are basically the leaf nodes in this case here. So when we have this graph here, let me make it more. When we have this graph here, right, what is the table? As I mentioned, there can be conditional probability tables, right? So what are these conditional probability tables? These are the probability of few variables depending on some conditions, right? So it is a set of conditional probability tables for each node, that is A, B, C, and D, each node in the graph. So for example, let's say for A probability, let's consider that the probability of A is it is negative is zero point 0.6 and it is positive, that is true, is zero point 0.4. So let's say the probability of A being false is zero point 0.6 and probability of A being true is 4.4, right? So that is if I have to convert it to percentage, the probability of A being false is 60% that it is going to be false, 40% that it is going to be true, right? And let's say we have to compute the relatable probability, that is for probability A and probability B, right? Probability of A and B. So we compute the probability of B over A, right? How do we compute that? It's like a truth table that we form 0, 0, 0, 1, 1, 0, 1, 1. Right? So similarly, false, 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 true, true, false, and true, true. So with these two possible values for the two modes A and B, these are the probabilities you can say. So don't worry about these values right now here. These are just for an example. They don't actually mean some specific things here. These are some random values which are taken here to make you understand. Right? So probability of both being false is very less. That is 0.01. Right? So that is just 1%. Probability of A being false and B being true is very much higher, nearly 99%, right? 0.99%. So the probability of A being true and B being false is zero point 0.7. Probability of A being true and B being true again, both being true, is zero point 0.3. Right? So that is the overall probability you can say just for two nodes, that is A and B. Similarly for B and C, B and D and so on. So you can go on constructing these probability tables, that is conditional probability. But the main idea here is to make you understand that what are these nodes here, how it is directed, why it is acyclic, right? And what are the conditional probability table associated with these nodes. So there are different more aspects associated to these things, but we will, as and when we proceed further in this module, we are going to see this, right? So this is the same thing that I'm talking about. What is the directed acyclic graph, right? A directed acyclic graph use only unidirectional arrows to show the direction of causation. So this is a unidirection, that is one direction. And each node A, B, C, and D here, each node in graph, they represent a particular variable, right? Any random variable from the set of variables that we have. So in this case, we have just four variables. So we have four nodes But the more the number of variables, more the number of nodes we have in a network, and more bigger network we construct. Right? They follow the general graph principle, such as node A is a parent of node B if there is an arrow from node A to node B. So this clearly says that the parent of B is node A, right? Because node A is directing it to node B, which is subsidiary, you can say. So that means that A is a parent of B, and uh, an arrow from any node x to any node y means x has direct influence on y. For example, node B pointing to node C as well as node B pointing to node D, right? So now B is an exceptional case where B has direct influence both on C as well as direct influence on D as well, right? But A has only a direct influence on just B, right? So this is a normal understanding, normal representation, and the explanation of this graph. What does a directed cyclic graph would look like, right? Also known as DAG. So there are a few more things associated to it, which we'll be covering up in the next class, right? And with this basic introduction being learned, let me show that. Yeah. So with this basic introduction, we are going to furthermore discuss what is Bayesian theorem, right? How to define a Bayesian theorem. Then what is concept learning in Bayesian theorem, right? We have already seen what is concept learning in the first module, right? Module one, when we discussed different problems in machine learning, how a system consider a thing as concept, and how does it learn that concept, right? So we are going to see similarly what is concept learning in Bayesian theorem, and a few more hypothesis least mean square hypothesis, LS and ML and LS error hypothesis, then ML for predicting probabilities, MDM principle, naive Bayes classifier, Bayesian belief network, and ultimately EM algorithm. So these are very broad algorithms, very important algorithms, plays important role in machine learning, basically for predicting some data, right? So in the next lecture onwards, we'll going to deep dive more into it and understand in detail what are these things and how it can be related to a real-time problems, right? So that's all for today's lecture. We'll meet in the next lecture. Thank you.